Okay, this is quadratic equations. We're going to go back and review to solve quadratics. We just did some quadratic equations by factoring, and I always try that first. I look at and say, is this factorable? All the way back to look for what's in common, difference of two squares, trinomials, sum and difference of two cubes, and factor by grouping. Factoring is one method. Okay. We also did in Algebra 2 completing the square and quadratic formula. In any of these, they are going to be in the form ax squared plus bx plus c equals 0. When you see the word quadratic equation, it's this exponent is a 2. The highest exponent is a 2. And it's going to be equal to 0. This term, when you hear me talk about this, this term is the quadratic term because it's got the 2 exponent. This one, bx, and that x is actually to the first power. This one is called the linear term. And the c is a constant. That's just a number like 5 or -7. It's just a constant. This whole thing is called a quadratic equation, not the quadratic formula. This one's called a quadratic equation. Okay. So far, for methods to solve, and you can abbreviate it, quadratic equations. First method is factoring. Some of you call it reverse FOIL. Some of you learned the first outer inner last method. Reverse that. We've done quadratic formula. Okay, and that's the x equals the opposite of b plus or minus the square root of b squared minus 4ac, and it's all over 2a. Make sure you extend that that square root symbol goes out over all of it. Then the third method is graphing. Okay, where you did that a bunch in Algebra 2, where you graphed parabolas and see where the parabolas cross the x-axis. Okay, and the fourth method is the completing the square. Okay. Okay, now I know you've done the completing the square and the quadratic formula, but we're going to go back and review it because it's been a while. Okay, I'm going to go through the steps to do it, and then I'm going to go through a couple of examples. So the steps to complete the square. And if you can't in your own mind say what those steps are, then you don't know it well enough. Okay, you need to be able to say these. First thing, you want to get it in what they call standard form, equal to 0. Okay, and that means get it like this: ax squared plus bx plus c equals 0. That's standard form equal to 0. Okay. Divide by a on both sides, and just use the equal sign. You want to divide by a, like if this number in front was a 5, you divide all the way across by 5 on both sides. Okay? Third step, get the constant term by itself on one side of the equal sign. You're going to get the constant term by itself. Now, we're trying to complete the square. When they say completing the square, what you're really doing is making it a trinomial square. Okay? So, on step 4, you're going to add the square of half the coefficient of the linear term to both sides. And you may have learned that last year. You take half the coefficient of the linear term and add the square of that to both sides. The wording's a little bit different. Same idea. 5th step. Factor the left side. So I'm assuming the right side's 0. Factor the left side, which is a trinomial square, because you just made it one. Factor the left side, that trinomial square, into the square of a binomial. Okay, factor the left side, the trinomial square, into the square of a binomial. 6th step, take the square root. Take the square root of both sides. Okay, take the square root of both sides. And then don't underestimate step 7. Don't work that much and then miss it because you don't know how to simplify a radical. That part's critical, that you know how to simplify the radical and reduce it correctly. Okay? Okay, so those are basically the steps that you go through to complete the square. Okay, now let's do it as an example. And they will just say in the directions solve by completing the square. Okay, so that's a specific method that they want you to use. Solve by completing the square. Okay, first example. Say they give you x squared plus 2x minus 15 equals 0. This one is factorable. What would that factor into? Turn around. X plus 5, right? And x minus 3. And then you could set each one equal to 0 because of the plus sign in the middle. Okay, but we're not going to work it by factoring. We're going to do it by completing the square. But it's a good idea to know what the answers are before you ever start. Okay, so if you go back up to the steps, it's already in standard form equal to 0. This a is 1, so dividing by 1 would not change anything. Get the oh, I left out the word constant. You guys need the word constant in here. Get the constant term by itself. So add 15 to the other side. Okay? Take half the coefficient of this linear term. Half of 2 would be 1. And add the square of that to both sides. Okay? That just made this a trinomial square. Okay? Now factor it back. X squared, I look at this. X squared is a perfect square of x. 1 squared is a perfect square of 1. This tells you the sign inside is positive. You factor it back into the square of a binomial. Okay? And it equals 16. Take the square root of both sides. Okay, all that's going to do is get rid of the square. So you'd have x plus 1. Now you do have to remember on this side that it's positive or negative. When you take the square root, there's a positive or negative out front, and it'd be positive or negative 4. Then you subtract 1 on both sides. So x equals, you have two answers here. You got -1 plus 4, or x equals a -1 minus 4. Okay? So x would equal 3, or x would equal -5. Okay? Okay, now let's check it graphically. Okay, on your calculators, clear out any equations. Okay, in the y sub 1, we're going to graph the x, use the x t theta n key right here. Do x squared plus 2x minus 15. Okay, and let's do zoom 6 to start. Zoom 6. You're not seeing the complete graph. I'd have to change my window a little bit. If I wanted to show the complete graph, I'd have to change my y min. Let's go down to like -20. There you get a complete graph. Okay, so this is going 1, 2, 3, 4, 5. It's crossing at -5. I'd have to change that a little bit, and then it's crossing at 3. So the calculator's checking our answer to make sure we're correct. It's where it crosses. Okay. If you end up on your problem, if you have a double root, like if I ended up with x equals 4 and x equals 4, then the parabola is just going to touch the x-axis. If you end up with an imaginary root, okay, then it's not going to cross the x-axis at all. Okay. And that one you can't solve for on there. Okay? Okay, any questions on that example? Okay, on this one, the a was 1. Okay, now let's do another example. Let's say I give you 3x squared minus 2x plus 1 equals 0. 3x squared minus 2x plus 1 equals 0. Okay? It's already in standard form equal to 0. First step, divide by a on both sides. Okay? So divide all the way across by 3 on both sides. Okay? That 3, it's a polynomial over a monomial. That 3 divides into each term. Okay, so this would give us x squared minus 2/3. Oh, by the way, in here when you're doing fractions, okay, and I'm trying to prevent some things for down the road in trig, don't write your fractions like this. Write your fractions like this. And there's a reason that I want you to use a horizontal fraction bar for trig. When we get really long things in trig, that diagonal fraction bar is going to cause problems. So try to switch over. Okay, so that 3 is going to divide. Okay. Take the constant term, get the constant term over by itself. Okay. So we need to subtract 1/3. So we'd have x squared. And you notice when I'm doing this, I'm leaving a space. You no longer have to show minus 1/3 underneath. If you can do it by sight, now if you need to write it down, go ahead and write it down. But if you don't, just do it by sight. Okay? Okay? Take half the coefficient of the linear term. And notice I don't care whether it's positive or negative, because when I add the square of it, when you add the square of something, it's always going to be positive, right? So take half the coefficient, half of the coefficient, of means times, half of 2/3. When you do that, those will reduce or divide out, so you end up with 1/3. You're going to take half the coefficient of the linear term, and you're going to add the square of that to both sides. Now, do I write down 1/9? Some teachers do. I don't. Okay, and the reason is that's already ready to factor back. Okay? Okay? X squared is a perfect square of x. 1/3 squared, a perfect square of 1/3. This tells me the sign that goes inside, and then square it. Okay? Equals. Now, this part, you do the scratch work out at the side. Don't do it in the middle of your problem. Do the scratch work out at the side. Now I go ahead and square it. Okay? Now I say I need a common denominator. When you add or subtract fractions, you got to get a common denominator, which would be 9. If I multiply this by 3, I've got to multiply the numerator by 3. Okay, so I end up with a negative 2/9. You agree with my arithmetic? Yes? Okay, get rid of this square. To get rid of the square, you take the square root of both sides. Okay? All that's going to do is get rid of the square. So you're at x minus 1/3 equals, now here's where you need that plus or minus. And I would, some of you are still at the stage where you need to split this up. -2 is -1 times 2. And I look for perfect squares inside there. So I'm going to leave this as x minus 1/3 equals plus or minus. Out of this, what can I take out? I. And out of this, what can I take out? 3. So I'm going to take out I divided by 3, and I still have the radical 2 that's actually left on top. Okay? Now add the 1/3. So I'd end up with x equals 1/3 plus or minus I radical 2, and it's all over 3. You may write it like that. Some authors write it like this, 1 plus or minus I radical 2 all over 3. That's the same answer. Okay? Okay? Will this graph cross the x-axis? No, because there's an imaginary in there. It's not going to cross the x-axis. Okay, so that's a couple of examples of completing the square. Okay? But to me, if you can't say those steps, okay, if you can't verbalize those steps, you're going to have difficulty on the problems. Okay, you got to be able to work it step by step. Okay? Okay, the other method. And basically the review is, if they give you something in this form, ax squared plus bx plus c equals 0, that is the quadratic equation. I always figure out what's my a, what's my b, what's my c. Okay, now, I see too many errors as a teacher. Everybody tries to sub in and simplify and do it all in one step. In the quadratic formula, it's the opposite of b, plus or minus the square root of b squared minus 4ac, and it's all over 2a. I figure out what's the a, the b, the c. I sub in. First thing, I write the formula down. Okay, you guys already ought to know to write the formula down and then sub in, and then you simplify. Don't try to sub in and simplify all in one step. Okay. Like if I gave you this as an example, say I gave you 5x squared minus 8x plus 3 equals 0. My a would be 5, my b would be -8, my c would be 3. So when I sub in, I'd get the opposite of a -8. I don't put 8 down there. Okay? I sub in and then I simplify. And I would do a -8 squared minus 4 times 5 times 3, and it's all over 2 times 5. When you do the -8 squared, you got to be very careful. You have to know a negative squared is always a positive. If you do it on the calculator, you're going to get an error. Okay? What the calculator is doing is order of operations. The calculator is doing -1 times 8 squared. Okay? So if you did it on the calculator, you got to do it inside parentheses. Then you get the right answer. So be careful on that. Okay? And if you simplify this, if we'd simplify this, we'd have x equals 8 plus or minus the square root of 64, okay, minus, what, 60? All over 10. Do you agree with that? Check my arithmetic. Okay, then you'd have x equals 8 plus or minus square root of 4 all over 10. And then we can go another step. X equals 8 plus or minus 2, and it's all over 10. And you have two answers there. 8 plus 2 would be 10 over 10, so that would be 1. The other one would be 8 minus 2. 8 minus 2 would be 6 over 10, and I get 3/5. Okay? And then you can check it. Okay? The other thing, remember from your Algebra 2, just a reminder, from your Algebra 2, remember the imaginaries always occur in conjugate pairs, or what they call conjugates. If I gave an answer like 5 plus 3i, okay, then my conjugate would be 5 minus 3i. They always occur in conjugate pairs. If I said negative 7 plus 2i was one answer, then negative 7 minus 2i is the conjugate pair. Okay? Okay? Hopefully that refreshes your memory on quadratics. Okay? And I'm going to give you time to work now.